Mark, the virtual floor is yours.
Thank you, Andy, and appreciate the kind introductions, good overviews for all the live audience. So those of you who are attending already know today we're going to be presenting on how systems engineers or the discipline of systems engineering can save entrepreneurship. And we're going to present a little bit about the problem, the challenge within entrepreneurship, its lack of a true science or a true engineering discipline. And then we're going to present some of our research and findings around what the solution to that issue might be, a methodology we call integrative venture engineering. Next slide, please. So Andy gave kind introductions to the live folks, so I'll briefly recap. My name is Mark Yde. I'm a venture architect with the firm Half Solved. I'm also co-chair of the INCOSE Integrative Venture Engineering Working Group, used to be called the New Venture Innovation Working Group, but now called Integrative Venture Engineering, which is the name of our methodology. That methodology was primarily advanced by Erik through a collaboration applied research program at Cornell University, where he worked with corporations on global innovation products for over 2 decades. Erik and I met at Cornell as I was finishing my master's in systems engineering. We came together as a team with Patrick and one of our other colleagues, Elsa, and Patrick is a product and business engineering expert. He's worked with Apple, Automatic, Facebook in product and business leadership roles. Next slide, please. So Erik is going to cover the concept of market creation. It sounds like a straightforward concept, but there's some important technical definitions that he'll overview, and we'll couch it in understanding of why engineers and scientific innovators should care about market creation, what it means to you guys. We're going to look at why market creation tends to be a really hard problem with a lot of complexity and uncertainty, building new businesses for new markets. And Erik's an overview in these first 2 points, the problem we knew about, the problem that we already know about, and the problems that he uncovered through his applied research programs over the last 2 decades. Then we'll talk about the current innovation paradigm within commercial innovation, which is lean startup. That tends to be the most pervasive paradigm, and I'll talk a bit about that and my learnings coming out of the venture capital space. Then Erik will return to the solution, which is our integrative venture engineering discipline, which is an application of systems engineering. And then Patrick will overview the Market Creators Lab, which is our vehicle for disseminating, socializing, and advancing market creation research. And we hope that all of you will participate in that. Next slide, please. Just a quick note. So questions, we'd like to field them in the Q&A chat box. At the end, I'll try to cherry pick a few of those that we'll cover, but the rest of them, Patrick will outline how we can take those questions through the MCL, the Market Creators Lab member forum. And Patrick will share some more at the end. Next slide, please. Erik, take over.
Yeah, everybody, first of all, just another shout out. Thank you to all the INCOSE team for making this possible today. I also wanted to thank 3 people in particular. You may or may not be on here today, but they've just been instrumental in getting us where we are today. It was about a 2-year process to get up the courage to get this technical working ground off the group off the ground. But it's Alejandro Salado, Erica Palmer, and Cliff Whitcomb. So if you guys are on here, just a big thanks. I'm not a systems engineer by training, and I felt a little kind of out of my depth and place, and they made me certainly feel welcome here, and gave us the encouragement to forge ahead. So I just want to contextualize what we mean by market creation, because it's a specific kind of entrepreneurship, and it truly is the holy grail of business. You know, market creation specifically means innovating new profitable business models, but that bring new core functionality into people's lives. So we've got a bunch of pictures here that capture different types of market creation innovations, you know, from the microwave to Steve Jobs and the family home computer, the very first, what became a credit card, the Diners Club card. To the right here, we've got microfinance, which was a way that we brought credit to people who were very low income, who didn't have any formal credit backgrounds or histories. And we see a bunch of new market creation activity happening today, from the attempts to make space travel something that becomes as routine as getting on a plane, to we all know the Impossible Burger and trying to find new ways of literally creating protein and bringing protein into the world. And why it's the holy grail is that these types of innovations, they do two things. One, they have huge impact in the world. They change people's lives. And the other thing, on the business side, they're really big profit growth engines. So they hit this kind of the sweet spot of what really kind of people in business are trying to do in the world. And I created this 2x2 here just to, again, help contextualize what we mean by this and to give it a little bit more of a scientific anchoring. So you can think about market creation or different types of innovation kind of on these two axes. You know, you can look on the vertical axis is core functionality. Like, is the core functionality that we're bringing into the world, is there a whole bunch of other options just like that are already out there? Are there lots of interchangeable alternatives? Like, are we bringing out another bag of potato chips where there's 20 other flavors? Are we in a situation where you can kind of get the basic functionality, but there's just really poor substitutes to the other extreme, to where like you just can't even get that functionality? And then we can look on the x-axis of like, who are we trying to reach? Are we trying to reach kind of the wealthier, the big mass market middle, or the large lower income group? And market creation for us is always, it plays in these top two. It's about, we're bringing in functionality that either today there's just some kind of a poor substitute for it, or ultimately it's not available. And we call these kind of the unsatisfied and unimagined markets, and we'll lump them together and sometimes say they're the unmarkets. And what this graph doesn't actually reveal is that 90+% of all innovation happens down in the served markets. That's where everyone puts their time and attention. And these top two, despite the fact that they're like they occupy kind of the bigger share of what's on here, there's very little attention put to it, and it's for good reason. It's just like, it is truly a black box challenge that people face today. And there's high complexity, there's just a lot of uncertainty, and it shows in the performance. Literally the numbers are, and this is always shocking when you actually peel under the surface, the chance of success of a market creating venture is less than 1%. And success here we mean by it becomes profitable. In other words, and if it's profitable, it can live on, in perpetuity. And they take a long time. The rule of thumb is like, if you're getting into this, you got to wait 10 years or more. And then in that whole time period, you're burning money. So it is a challenge that is really daunting and almost off-putting to a lot of people because of this incredibly high risk that it presents. But the thing, what we now know is that high failure rate, that long timeline, the really high cash burn, it isn't the nature just of the challenge. It's not just inherently how market creation presents itself, but it's actually caused by how we're building, how we're trying to solve for these ventures is literally causing the very problem. And Mark's going to double click and get into this a little bit more in the presentation in just a bit. But again, just want to kind of contextualize what we mean by market creation, why it's so essential and why we want to be solving for it. But then also like what we're actually up against. So I'll take about 20 minutes and I want to put my finger on and really isolate kind of the key problem. I just want to what's the big takeaway and learning that we've had about what's going on under the hood in these ventures and why they have such really kind of bad performance. And at the same time, why is systems engineering the go-to discipline to solve the challenge? All right. So I'm going to turn the clock back 25 years. When I got involved into this space, it was around 2000. And back then, the problem that everyone honed in on about why is it hard, is that there's really a big cost barrier. It's not that someone hadn't ever thought about trying this or to solve the problem. These unmarkets remain dormant because there is literally an order of magnitude cost gap between what the customer can pay and what it's going to cost you to make and sell and deliver that solution. So take our classic Henry Ford example. So a solution for the functionality of mobility via an engine-powered carriage. So I've kind of defined the core functionality of a vehicle. Yeah, it existed back at his time, but it cost $1,500. And at that time, $1,500 literally was, the ultra wealthy could afford that. And the only way he was going to ever make that and bring it to the mass market, move over into the big middle, is by dropping that price down to like 300, an 80% cost decrease. And the whole thing is like, there's no way you're going to optimize away 80% of your cost structure. Like, you're going to have to fundamentally re-engineer the business model, as he did. So solving that problem was the focus of my doctoral work in a learning lab that we set up at Cornell in the early 2000s. We called it the BOP Learning Lab. The acronym BOP, by the way, stands for Base of the Economic Pyramid. Our focus was actually really on the low-income emerging markets, where that cost gap was really particularly daunting. And the goal of the lab in my dissertation was to actually create a methodology so that we could systematically create new profitable business models. And we had a whole number of corporate partners who were involved, and they were all agreed to test out the methodology. We ended up having 4 pilot tests, and they ran sequentially. We had one in Kenya, one in India, Mexico, and the US. And it was a great learning opportunity because they ran sequentially, we could take learnings from one and kind of apply into the next. So the methodology could keep iterating. In our V1 of the methodology, it drew on these very kind of, at the time, there were these new emerging theories and practices. What we ended up with was a mashup of what I would call kind of these deep customer research tools like human-centered design, as well as risk minimization strategies. There was an approach called discovery-based planning and real options investing. And the basic process could be boiled down to just 4 main steps. We're like, all right, let's get out and apply these tools systematically to really deeply listen to the customer, really hear the voice of the customer. What's the problem? What's the user's problem? Next, we'd be like, all right, let's now keep working with them to come up with the solution that they are a part of, really kind of getting them to put their own ideas and thoughts such that we're creating something, again, that is already kind of being designed with their own, I guess, kind of their own hands kind of involved in shaping it. We then launch a small pilot. We're like, all right, we got this kind of basic core product idea. Let's just get out and into the market and get it out there and start running the business. And the goal was, start small, but let's experiment. Let's kind of organically evolve and figure out how to get this thing to profitability. And all those ventures over the course of that basically 10 years, they all ended up kind of having the same fate. They all failed. Every one of them, and it probably was about 3 to 5 years, not a single one could get to profitability, and they were all closed down. But it was the way they failed is that I wanted to focus on, because they all experienced what I call it the profitability treadmill. And it played out something like this. So we would launch, and we would launch, and we would get customers. And as we progressed, each one, we got better and better at getting customers right away. We would get sales. But, a year in, we're still losing money. We're like, all right, well, let's address the top line of the profitability equation. Let's grow sales. And so we'd have a suite of things that we were doing. First thing is like, let's add more value into the product. Let's try to kind of expand the offering. Let's expand, do more marketing, more promos, do more things to get the product in front of customers, give them a chance to really experience it. And we'd also look for new segments. Where are there other customers that we feel like, could, if you look at kind of like the early adopters and later adopters, who are these later adopters that we can start reaching out to? And the good news is sales would rise. Bad news was, so would our costs, which then, triggered us to say, all right, well, let's keep doing what we're doing, but let's now work on the cost side. And so we go down kind of somewhat of, I'd say, kind of a usual kind of suite of things. We'd be like, all right, how can we lower the actual kind of cost of goods sold? How do we source less expensive components, ingredients, packaging? How can we streamline operations? Are there ways that we can get economies of scale in terms of how things are being shipped and delivered? Can we aggregate sales and distribution? Can we find places where we can, we can just get more bang for our buck for doing any of our marketing and sales efforts? We would get costs to decrease, but the flip side is all the sales would stagnate. So it was like, we kept getting caught into this trap of like, we do work to drive sales would improve, costs would rise. We do work to cut costs, sales would stagnate. And I'm going to pause for just a second. And I know we're not set up to like engage in a conversation, but it's like, if you put your systems engineering lens hat on, like what concept describes for you what we were experiencing here? I don't know if somebody could like throw a couple things in the chat. If Andy, you could, I'll give you maybe 10 seconds. We're not got a bunch of dead time, but are there any concepts that come to mind that really would capture from an engineer's kind of perspective what this dynamic is? Anything drop into a chat?
Nothing's gone into the queue.
Nothing, but I'll jump in.
Yeah.
I'll jump in there. The concept that probably should be evoked is negative interaction effects. And when you really think about this is what Erik's saying. There are trade-offs. As costs rise, sales decrease. As sales increase, costs need to be cut. The issue of negative interaction effects is not just something that happens in consumer markets. There aren't just economic trade-offs in consumer markets. We have to think about, and this is what's important for this audience as well, is we're not just talking about consumers in the sense of individual customers. We're talking about whether you're in aerospace, defense, complex materials, whatever. You ultimately are going to face engineering trade-offs. And as you increase performance in one engineering parameter or quality, you may face negative interaction effects that lead to a decrease in quality in another engineering parameter. So this extends way beyond just consumer markets.
Awesome. Thank you for that, Mark. Yeah, anytime, as you heard from the introductions, Mark is a systems engineer. I'm not, and so it's really helpful, Mark. At times I'll ask if he can kind of come in and provide almost more of like a systems engineering kind of explanation, a lens on this. But so this is all going on, and we got to the point where like, why? Like, why is it that we've got really good teams on the ground? We got really top-notch people working on these things. We're doing it for a long time. We're experimenting. Like, what is it that's going on? And I'm still to this day, I can't remember, why we did this, but we ran the financial numbers in a very different way. And it actually forms the basis of this at-scale financial modeling technique that we've developed, which I'll talk about a little bit later. But we asked the question, what would it take for us to be profitable at the last mile operating unit? So kind of at that point where the sales transaction, the lowest level in an organization where kind of the sales transaction takes place. We're like, what would it take for that last mile operating unit to be profitable, either in terms of like increasing penetration in sales or cutting costs? And the answer was really bad. He came back and it's like, we've either got to cut costs by like 40%, keeping our sales constant, or we've got to increase our sales by about 80%, keeping the cost base consistent. And either option was like, was a non-starter. And it was that point that there was this literally the cold shower realization that like this venture has been doomed from the moment we came up with the product idea. We were in truly like a dead-end venture. There was no business model that we were ever going to discover or experiment or evolve our way to that could profitably make, sell, deliver, and get paid for that basic product idea we had. So it's like the poor guy here on the right. Like, I don't care how much experimentation he's going to do. Like, he's never going to fly with starting with this idea. And what made it worse again was we suddenly realized we could have known this at the start before we had gone through $500,000 of running this pilot. Same with this guy, an aerospace engineer could come in and very quickly explain like it's just not worth your time because you're never going to get off the ground. It's fundamentally flawed. And this is what triggered us to suddenly start looking for like, where are their theory bases? Where is there a discipline that deals with kind of designing and building a novel system? Because a business, everybody knows, it's kind of a conventional understanding. A business is a system. We got tons of parts, everything's coordinating, a lot of emergent functions. But like, where do we go to actually figure out how to build these things? And I remember we landed on the CBOC on that wiki, and I literally thought we had hit a gold mine because I felt like this is it. It's literally speaking and talking about the problems that we're seeing in a way that really captured the dynamic. And I felt like we were putting on these like night vision goggles as this little vision, as the picture here shows. And before, it's like we're looking at the darkness, but now suddenly it's like you're seeing things, that of what was happening that just now jump out that before you just couldn't see at all. And what really took shape using the systems engineering lens was kind of this key problem behind that profitability treadmill. We and everybody else, as I started, we were all focused on the concept of the business model. And the business model, it's a firm level concept. Every company has a business model. It's like a fingerprint. And there's different definitions about what it, but generally, a business model is about how each company goes about organizing all these different components so that they can make, sell, deliver, and get paid for a product. So it would be akin to an engineering plan for a specific bridge, like the Golden Gate Bridge that I have here. And it's the business model that determines my firm's profits, how much money I'm going to make relative to other companies, my competitors. An engineering plan would do the same thing. It determines how good this actual bridge in this place is going to perform, this specific use case. But after all this experience that we had running these failed ventures, we were trying to iterate the model. It just something became clear that something was lurking under the surface of the water that was actually kind of constrained the performance of the business model. There's some invisible hand that was kind of in operation. And kind of, I guess, what systems engineering brought to light is like that invisible hand or that problem. It sits with what we now understand is the business architecture, kind of the core architecture of the business itself. And the core business architecture, it's essentially, it's the DNA that is shared by all companies' business models in a given market. So, while Ford, Toyota, and Mercedes, everybody has, each of those, they have a very different business model, but they all share the same business architecture. Same for McDonald's, Burger King, and Wendy's. All of them share the same business architecture, even though their business models are very different. And they also all look similar. Ford, Toyota, Mercedes look alike, as do McDonald's, Burger King, and Wendy's. And that's because the business architecture manifests as a common form factor. Like there's a basic shape that the product and operations have to take when they're resting on that architecture. And again, it's the same thing with the Golden Gate Bridge. Yes, it's a one-of-a-kind engineering plan, but that plan rests on a suspension bridge architecture. So it's why it looks like, the Brooklyn Bridge and the Pearl Bridge in Japan. They look alike despite all these idiosyncratic differences. And the key thing is that while the business model is determining firm level profits, it's the business architecture that actually establishes and solves for industry level commercial viability. In other words, commercial viability of a solution sits at the level of the architecture. And again, same thing with the bridge. The reason why all three of the Brooklyn Bridge, the Golden Gate, and the Pearl Bridge all stand up is because of the architecture, the suspension bridge architecture. It's that architecture that lets them stand up. And again, I guess the big insight that then kind of closes the loop on the profitability treadmill, is that it's this business architecture. It actually bounds the performance potential of the business model. It caps how much value the business model can create for the customer. And it also creates a cost floor at which you can make, sell, deliver, and get paid for the product. So it's why if you look at the performance of Ford, Mercedes, and Toyota, they all kind of fluctuate in the same range. Their operating margins, cost of goods sold, they all kind of work within a range. Same for all these fast food chains. And it's true for a bridge architecture as well. There are limits where you can use suspension bridge architecture. It's why we've got all these other types of bridge architectures. I just want to hit a pause there because, again, per my previous comment, I'd like to just say, Mark, is there anything that you feel like just would be helpful to maybe rephrase, explain to give it more of a systems engineering foundation?
Yeah. Well, the bridge metaphor we're hoping will hit home especially with anybody who's a real model-based systems engineer or a pattern-based systems engineer. The idea of the architecture, both in bridges and in business, it's an abstraction. all these individual bridges, the Golden Gate Bridge, this is just an instantiation of that overall architecture. The Golden Gate Bridge, it works in a specific context, but the design, the architecture of suspension bridges, that pattern is way more pervasive. It sets the constraints on the context in which that bridge can be built, but the specific parameters of that bridge, of the Golden Gate Bridge, its length, its ability to undergo wear and tear, torsion, the materials used, that's the business model. So yeah, I think that's a great metaphor that you use for the difference between architecture and model.
It's slightly off script, but like, what's funny is like, I might imagine that some people who are in engineering think like, well, this seems kind of like, well, obvious. And it's like, but in management science, the concept of an architecture does not exist. And it actually makes sense when you think about it. Management science, by definition, is about managing something that's already been created. So like literally the discipline and what we know, where engineering has infused management knowledge and science has been more in like, how do you, operations and logistics. In other words, like the optimization and of running an established system. But there is no science in business about creating a completely new form, really. So I might be talking about this in such an excited way because I feel like, we've uncovered this brand new concept. Whereas I think in other fields, it probably seems like we're behind the times. Okay, and so what's causing the profitability treadmill phenomenon is that the core business architectures that we were almost like unknowingly creating, they were all, we use the term fragile. And we created this graph just more as a way to kind of visualize and bring to life what we mean by a fragile architecture. And so what this graph shows, it's got cost curves of 3 different business architectures. Let me just quickly explain the graph here. So the vertical axis, that's the unit cost of a product. And it would be the unit cost of a product, coming out of any of the business models that fall on each one of those curves that's possible using that business architecture. So if we see the business architecture again is like the DNA, there's a lot of different instantiations of how you can do it. So but all those business models kind of again are bound in terms of what its cost, what that cost floor can be. That dotted line that cuts across. So think of that, that's the customer value line. That's the amount of value. And I've kind of fixed it here again, just for illustrative purposes. Think of that, that's the amount of value the customer gets from the products that are being, made, sold, delivered through those business models on the business architectures. And customer value proxy is essentially for like the price the customer will pay. So in architecture A's case, this green line here, architecture A, it has a robust path to profitability because that entire cost curve, the cost curve for the whole architecture sits below the customer value line. So you can think of that as like literally almost any business model I can cook up, like working from that architecture, like I'll be able to get that product to the customer at a cost below what they will pay for it. The other two, these are fragile. So the yellow one, architecture B, this one has a narrow path to profitability. And that's because that curve, only a small piece of it sits below the customer value line. So there's only a few really kind of optimal business model configurations that are going to let you bring that solution to the customer at a price that you can be profitable at. In the case of C, there is just no path to profitability. Literally, the entire cost curve sits above it. So no matter how much you try to optimize, no matter how much you try to squeeze out cost and streamline finding economies of scale, you're never going to be able to get that cost down below what the value the customer gets. So looking back at what we were experiencing and why we land into these really long development cycles, we spent 10 years experimenting. It's because we're either, and who knows where we are, we're either we're in a B or C, but we're definitely fragile. And it's why we can't ever figure out how to get to profitability, no matter how many people we throw at it, no matter how much we experiment. Okay, I'm gonna share more about ultimately what we mean by how to create and actually innovate a robust architecture when we get to talking about IDE. But first, I'm going to kick it back over to Mark. And Mark's going to talk about what was going on in the world of entrepreneurship while we were busy, plumbing the depths of systems engineering.
Yeah, thank you, Erik. So yeah, as Erik was doing all this research, the rest of us were being introduced to the lean startup paradigm. You can click to the next slide, please. Yeah, so lean came out of the Silicon Valley world. It was an innovation methodology that was primarily oriented around software, developed by Steve Blank, who's a Silicon Valley entrepreneur, and really formalized by a guy, Erik Ries, who wrote the book, The Lean Startup. And the basic premise of lean is that businesses are extremely uncertain. Our ability to figure out what a customer wants, what they need, and how to deliver at a price point that they're able to afford, that's uncertain. And until we really go out and do in-depth customer research. Click through, please. So the best way to start both the customer development and the fundraising process, importantly, is to launch a minimum viable product. We need to get something in our hands that we can actually talk to investors about and we can talk to customers about, but mostly customers. And the idea is then to put out that product with the minimum viable functionality, similar to a prototype, get it into market, experiment, taste the customer feedback, and then iterate rapidly, introducing new product features, doing A/B testing, doing whatever you can to get that MVP to a form where you get some sort of product market fit. Product market fit is often poorly defined. It's often quantitative, but the idea is essentially, can we get a critical mass of customers who are willing to pay for the MVP that we're delivering? If you can do that, that's great. If not, the idea of lean is that we can always pivot. We can introduce more product features. We can entirely re-engineer the product. But ultimately, that means that necessitates the invention of a new business model to then serve that new product. All of this is done in situ. It's done in market. And it's the water that we swim in. And it comes out of the software space, but it's permeated all other domains within innovation. Next, please. And when we really look at that iterative process, the idea of introducing product, co-creating with the customer, introducing a new business model to try to serve that product, and then iterating on or pivoting on that business model to try to find profitability. That was exactly what Erik just described that they faced with the treadmill, with the profitability treadmill, as they had to either cut costs or they had to increase sales in order to actually achieve profits at scale. And it's the same problem that model of cyclical innovation, iteration, and pivoting is what was formalized in the lean startup method.
Mark, I would just might add, because I feel like there's a bit of humility I want to kind of inject in here. Is like, we're highlighting this problem with lean startup and how people today are, but like it's the same thing we were doing. We fell into that very same kind of approach because there are lots of there were theories out there that have become popular that kind of led you in this direction. So like our protocol literally was like in very ways kind of an early version of lean startup. So it's not that someone else, didn't get it right. Like we got it fundamentally wrong.
Thank you. Yeah, definitely important to highlight. And so let's go back to the idea of the MVP. That's the product. We start with the product in lean startup. This is similar to locking in a form. In systems engineering training, we're hit over the head with the idea of form versus function, and we focus on functional requirements for a reason. As soon as you lock in a form, the potential for negative interaction effects, the available trade-offs within the search space become inherently limited every time we lock in a form, every time we lock in a part. We would never design a system around a single tire, for example. But the Rube Goldberg is a perfect metaphor for this. It's an obsession with forms. It's an obsession with putting together a bunch of parts in a way that's quirky and fun. But really what it is a demonstration of a kludge, the idea of quick fixes and these kinds of small iterations, piecing together the parts part by part. And ultimately, that's what happens when you lock in the product form and then solve for the business model later. The business model is not, in our framework, is not just meant to serve the product. The product and the business model should be treated as inseparable. They're both serving the function of delivering profits at scale for the business. Delivering the functionality to the customer is obviously a key core part of that, but that doesn't mean you should lock in the product form at the front. As soon as you lock in that, you're also locking in all the operational challenges that go with it, all of the logistical challenges, the manufacturing, the supply chains, those are all locked in once you've defined the basic form factor of the product. And that the lean model and through our research has been shown to introduce operational challenges, further adoption challenges beyond just solving the customer need. It introduces adoption challenges that show up in the form of sales and marketing and branding. And then competitive challenges. There's nothing about customer adoption that necessitates a competitive advantage. The idea, can you click to the next slide, please? This issue of locking in the product and then searching for the business model is compounded by the live in-market aspect of the lean startup paradigm. In software, this made sense. You can put a piece of software out into the market. You can get customer feedback at scale from a massive amount of people, even a global market potentially. You can take that, you can A/B test, you can iterate, and you can deliver new code in a period of hours. In any other form, especially in hardware and complex systems, this is akin to building the plane while you're flying it. Can you click through, Eric, please? And the only thing that we put in the lean startup process, what we put in the hands before we ask them to develop the business model, is something called the business model canvas. In essence, it's a parts list. We say, what is your value proposition? What are the revenue streams? What is the cost structure? And then we tell them to go out and start testing this product in combination with this business model in market. But in reality, I would ask the system engineers, do you treat the bill of materials as a model for how the system is going to work? You wouldn't, because the bill of materials is not dynamic. It doesn't incorporate any sort of performance parameters, and it doesn't show the interface requirements that happen in between the different components, the different functions within the business model and the product. But that's what they're given. That's what we're given as entrepreneurs within the lean startup paradigm. We're given a parts list essentially, and we're asked to piece together the business model in order to serve the product as it's live in market. That leads to massive cash outlays, massive expenditures of time just to iterate and pivot the business model to try to find a profitable engine. The output of this is what we call zombie industries. I'll highlight a few of these, but in essence, when you think about what lean has done, it's introduced a lot of rapid customer adoption products. A lot of the software that we love and a lot of the products we use, I'll highlight the at-home meal kit industry. But zombie industries we define as something that can exhibit rapid customer adoption, but ultimately is going to be sustained through venture capital, private equity, or public equity. Essentially, these products that we like to use as consumers or as enterprises are not subsidized by profits on the business themselves. They're subsidized by equity. They're subsidized by investment. Blue Apron is a classic example. A lot of us in the US, especially in North America, have used Blue Apron or HelloFresh, one of the competitors in at-home meal kit delivery. And in the late 2010s, this was awesome. We're all excited to have this new core functionality, fresh delivered ingredients that we could chop up and cook at home. Blue Apron was one of the early winners. They exhibited massive investment. They achieved $730 million in venture capital investment. At peak, prior to their IPO, they were valued at $3.2 billion. All of that sounds like a resounding success story. And they were built within this paradigm of lean, as was HelloFresh, as were all the others, this model of rapid customer development and achieving scale quickly. But then you have to look then at the ultimate outcome. And in 2023, Blue Apron was sold for $103 million. So the peak, $3.2 billion valuation to $103 million. That's over 96% of a markdown on their valuation over that period of time. A massive cut. So what seems like sort of a nominal or superficial success story was actually a huge failure. And that, in our language, that's happening at the level of the industry business architecture. And it's a recurring problem. So if you look at other at-home meal kit companies, another one is Freshly, which is a meal delivery company I'd never even heard of until I started to do this research, was acquired by Nestle for $1.5 billion in 2020. In 2023, they shut down operations in the company and were sued. Nestle was sued by its investors for missing their earnings mark. So this is a recurring problem, is that this lean startup paradigm introduces these companies that exhibit massive customer adoption, rapid growth. They get to these huge scaled revenues, 500 million to $1 billion. They court lots of venture capital money. They IPO, they court public equity money, and ultimately they can never turn a profit. So they can't sustain themselves. They can't continue to deliver the functionality that consumers come to rely upon. And in spite of all of this, the paradigm seems to persist. And we have a few hypotheses for why this is happening, but one of the main ones is that there's a top-down pressure. Entrepreneurs, business builders tend to follow the money, and the asset class that serves early stage innovation is venture capital. Venture capital funds are called funds for a reason. They don't invest in any single individual company and say, let's call it quits. Let's build this into a big, bold company that's going to deliver profits at scale. Venture capital funds, anybody who works in finance knows this, they build a portfolio. The idea is to spread out their risk, to build a portfolio so that even if most of the companies fail, if a few of them succeed, then they'll still be able to return money to investors above their expectations, above the market rate. So in a sense, venture capital benefits from the overall paradigm of lots of entrepreneurs getting lots of products in the market, because then they can pick out the winners. They can choose the few that they want to keep advancing, they want to keep funding, and they want to get to market. The Tina problem. So this is the venture capital creates kind of a top-down effect, a pressure from funders. The bottom-up effect is that academics and as Erik mentioned earlier, there's a whole science of management. There's operational science, there's operational research, there's financial engineering, there's supply chain analytics. We have all these advanced simulation methods for a mature science or mature business analytics. But academics and universities, in a sense, have kind of failed entrepreneurs in that we haven't introduced a viable alternative. We don't have a systematized, codified framework as an alternative to lean startup in order to advance new ventures to market. And that's the Tina problem. There is no alternative. Together, these two things have created the lean startup paradigm. And when we say paradigm, we're talking about there's a book called The Structure of Scientific Revolutions. Thomas Kuhn was a philosopher of science who introduced the idea of paradigm shifts, that science doesn't always progress through slow incremental change, but often there are these massive leaps that flip all of the models and theories on their head and introduce new experimental methods and ways of seeing the world. And the classic example is the original geocentric model of viewing the planets in our solar system. Well, not our solar system at the time, but everything was revolving around Earth in circular orbits. With Galileo, Kepler, Copernicus, introduction of new lenses, new telescope technology, we had to start accounting for all these anomalies, all these failures of predictions. And that ultimately led to an entirely new worldview, entirely new paradigm in the science of astronomy, and the heliocentric model, where we realized that everything, including Earth, was revolving around the sun within our solar system. And in that sense, lean is the paradigm. It's because there's no alternative, and because the major powers within the entrepreneurial ecosystem, which is venture capital funding, because they're incentivized to perpetuate that model, and there's not an alternative, that paradigm tends to persist. And there's a overwhelming survivorship bias. And when we look back at those zombie industries, we tend to look at the survivors of the paradigm, and we like to articulate those as success stories, because a lot of people within the innovation ecosystem benefit from those success stories, Ubers, the Amazons, but they don't look at the universe of companies that tried to build like an Uber, tried to build like an Amazon, and failed outright. All of the entrepreneurs, all the founders, all the investors who lost their shirt, and all the employees of those startups whose stock options went to zero. So we face this a lot when we talk about lean startup and its sort of logical, rationalistic, and even empirical failures. We still come up against the issue of statistical fallacy rooted in the survivorship bias, that people don't look at the negative cases because usually there's no data on the negative cases. There only tends to be data on the positive cases. Next slide, please. Yeah, so I'll turn it back. This is we articulated the issue, and now Erik will continue on and focus on applying systems engineering through the integrative venture engineering model.
Cool. Thanks, Mark. So let's just jump in to how we've applied systems engineering to venture creation. And we call the methodology integrative venture engineering. It's meant to be It's not like quote, our methodology. It's literally just our generic term for what is when you apply systems engineering to the specific use case. And just to put things in context, we've had a lot of reps at this. We've been at this for about 15 years, and we've applied some version of what we call IDE to more than a couple of dozen applications. So we've been continuously evolving, kind of getting chances to test out new techniques and solutions, and it's just been continually evolving. So I feel like we've truly opened up the black box. And IDE, it's reached a point where there's this solid foundation in place. It feels like we've got almost like a real discipline and a new science that's being birthed. And ultimately, again, the goal of that discipline and that science is to do three things. We are trying to create a step change in success rates. We're trying to drive down, decrease the time that it takes to get ventures to operating profitability. And we're trying to drive down all the money that's involved in getting it. And IDE traces the classic systems engineering V model. We've been working through the V model and crafting a venture creation V model. And so it follows a very same pathway. We start with what we call a prime commercial opportunity. We don't start with a product idea, but we take a technology and we say, what's the core functionality? What's the key problem we're solving? And that gives us visibility into what's the commercial opportunity that holds the best likelihood of success. And then we design and validate top-down in levels, always against requirements. We start with the core business architecture and form factor, work our way down through what we call a 4D product, finish up with key operations and management. The entire time going through here, modeling and simulating is being used, and we're always evaluating robustness operationally and financially. I mean, we really took a lot of inspiration from the turn to model-based systems engineering. And then on the right-hand side, we're building and validating bottom-up. We're working against performance specs that we generate using the models and simulation, working from individual business components, obviously there's the product, but there's something like, what's a sales call? And then we work our way up, through a series of integration tests, culminating with a final integration test that we term a minimum representative pilot, kind of another small scale that captures the variability that we've modeled into the simulation and tests out the key drivers, the biggest risk factors, if you will, to profitability. And out of the whole process, we kick out what we call a maximum viable venture.
Erik, could I interrupt briefly? Your reminders are on the screen in the bottom right. If you could just dismiss those. I'm sorry? Your screen sharing is showing the reminders in the bottom corner, but you can leave it.
Oh, I'm sorry. It's on my other screen.
Yeah, leave it for now then. It's all right.
No, I can. Oh, for God's sake.
You can leave it.
Okay. My apologies for that, guys. I didn't realize it on my other screen. So what I just wanted to cover here is there's so much we could go through. I have a bad habit of delving into details and getting lost in the weeds. So I've disciplined myself to say, let me just pick 4 key breakthroughs that we've I guess generated in harnessing systems engineering for this application. Because we quickly discovered you don't just do systems engineering to build a venture. The very science, the concepts, bunch of the tools that are already well established in other applications, as we were saying earlier, they don't exist in management science. And the first big breakthrough that we had is we've defined and validated 10 architectural requirements, so you call them all functional requirements, that are applicable to all market creating ventures. And you'll see where these kind of show up in the V model. The second thing is we've actually figured out how do you actually radically shift the cost structure of a business architecture, going back to that very initial question, back from 2000, what is fundamentally governing the cost structure? How do you create a business architecture that brings it down? We've figured out, we created, I call it a KPI, key performance indicator that we can use to evaluate and measure robustness of a venture. And the last thing is we figured out how to go about actually building a high fidelity financial model that actually is simulating the underlying architecture, the logic, and lets us probe it for robustness. So on the defining architectural requirements, we've created a tool. I guess we've put all what we've learned into a tool we call the Business Architecture Logic Model. It's the acronym, the BALM, and I can't reproduce it here because it's big and it's got a lot of detail on it. So what I'll do is I'm just going to show up little bits and pieces of it and explain it kind of at a really high level. But it's fundamentally, it is a universal roadmap. That's how I think of it. It's a roadmap for innovating in architecture, but then also evaluating that architecture for its logical validity. And it consists of 3 foundational functions that ultimately dictate commercial viability, whether a business can stand up. And it's true for all market creating ventures. In other words, these are 3 functions that fundamentally drive the cost and value curve. And again, not going to go into detail at this point, but neutralizing what we call the value barrier, normalizing a customer routine, and dictating the competitive landscape. Now, in the BALM, then what we've done for each of these functions, we've isolated what I call literally the first principle science of like, well, what do you actually have to solve for in order to deliver on these functions? So if you look up here in function 1, neutralize the value barrier, there's 3, and these are literally the essential most things that you have to do in order to be able to credibly neutralize the value barrier. And the reason why there is this big cost gap that otherwise stands between you and being able to bring the solution to market. The next thing we've done is we've sequenced all these 10 requirements, and we've created a pathway for solving each of them. You have to work through these 10 requirements in the order that we have them here. And so, for example, for circumvent the at-scale bottleneck, this R1, the very first thing, in order to solve for it and actually circumvent the at-scale bottleneck, you have to do 3. You have to start out by first saying, well, what is the conventional business architecture that otherwise would be used? Within that conventional architecture, where is there the critical limiting operation when this business will be running at scale? I.e., what is the thing that drives up, disproportionately my cost structure and creates a floor that I can't penetrate under? Given the nature of that problem, we identify what we call, what's a workaround theory of change? What is a theory base that we could draw on that addresses the class of problem that critical limiting operation presents? And then ultimately, what's the workaround strategy? How do we take that theory of change and apply it in this specific case? All right, the second big breakthrough, shifting the cost curve. So how do you go about fundamentally changing what otherwise and addressing that big cost gap? This was literally probably, in some ways, I feel like almost the biggest breakthrough. And what we discovered is you have to think about, we use the phrase, you have to productize all of these strategies that are needed to solve for these 10 requirements. We've got 10 requirements that solve for commercial viability. And what we want to do is we want to shape the product so that essentially we're harnessing the product to solve for a bunch of the problems that otherwise get relegated to the business model. So if you go back to what we were saying, kind of like the flaw in lean startup, the flaw in our BOP protocol was like, we talked to the customer and then came up with an initial product idea and then tried to figure out the business model, then try to figure out how do you make, sell, deliver, and get paid for it. What we're saying is here is you want to bake in all these strategies to address these different commercial challenges into the shape of the product. An important thing is we want to do it in the most elegant way. Like what's the simplest shape of the form of product that would achieve all that? And so what ends up happening is like we're shaping the product and the operations around it, it almost like becomes the negative space. The operations kind of just fall out of the product form. So they almost like naturally map onto the product. The third key breakthrough was like, how do we go about evaluating, what we're doing and knowing we can logically evaluate it using the business architecture logic model. How do we evaluate it financially? And the metric that we've developed and we use, we call it the market creation margin. And it is truly, it's a measure of a venture's, the margin of safety. By that, we mean like, it's the margin of safety that lets you take what, there's a phrase that comes out of the lean startup, but it's used in a different way. But we want to be able to take a punch in the mouth and still have this venture be profitable. And by a punch in the mouth, there's 3 kinds of punches you can get as a business. One, It's like there's uncertainty. The actual costs I'll have to make, sell, and deliver might rise and be higher than what I thought. There's uncertainty as how many customers. The number of customers might be lower than what I was forecasting. And there's also like, what price are they going to pay? So we want to create a margin of safety that lets us absorb variability. In the market creation margin, kind of the math behind it is we take the low end of what we calculate as a customer willingness to pay range. We subtract out the high end of what we calculate as the credible kind of unit cost range. We divide that by the unit cost range. So in this case, we've got a 50% market creation margin. That means our cost base can rise by 50% and we can still be profitable when we get into market. And we've been using a target of 30%, and that's been a bit of a rule of thumb just as a team. And it comes out of the kind of the research that shows that basically 70% of your cost structure is already locked in at the architecture stage. And the last big breakthrough was on this thing I've alluded to earlier about creating kind of a high fidelity financial model. And the technique tool process, we call it at-scale financial modeling. And it is a systematic approach for evaluating the financial robustness of the architecture. So we want a way to evaluate mathematically the logic of how something works. And we ended up having to create a new way to do financial modeling because everyone does financial modeling. There's no shortage of people running numbers. It's just that the way conventionally numbers are run, there's a lot of detail, a lot of resolution, but they actually have very low fidelity. They're not capturing kind of the logic. And that's because most conventional financial modeling is designed as a reporting tool. It's meant to have a standardized reporting, not necessarily as a design tool. And so what ends up happening, costs and sales become disconnected in these models. And once that happens, you can make your financial model say whatever you want it to be. And so it literally becomes like a rubber stamp as opposed to an actual design tool. And I'm not going to get into any of the details other than like, it's just a few key points of what's kind of uniquely different. We start off with, we actually kind of start at the end. We bound the venture. We fix what are the credible at-scale unit sales. Then we start working backwards. We define activity drivers. It's very much like cost accounting where it's used as activity drivers, but we look for activity drivers that determine, how much work has to be performed to manage the at-scale unit costs, unit sales. And then we attach resources to all those activities. And when all that's said and done, we're able to come out with and calculate what we call kind of that fully loaded unit cost, i.e. the required price that captures, what investors need as a return. And the one key challenge that we always had with that was like, it's one thing to say that you need to kind of identify activities and resources, but it's another thing to actually do it. And it's just really difficult without having what we found, like we need to create almost like different visual representations. The same way you do with a house, you can have like a planar view, kind of a front-on view, cross sections. And so we've got 3 different ways that we visually model so that it helps us identify the activities and resources. We use what we call a customer transformation journey, which gives us an ability to say, like, in order to change kind of customers' mental, emotional, and behavioral states to get them to go through the customer journey, what is the actual product that we have to kind of insert into it? The at-scale operational model is a way for us to then visualize and trace the movement of this product from the head office down to the customer. And then our last one, the at-scale resourcing model, is a way for us to then take kind of this visual of where the movement and attach like who's responsible from a personnel standpoint, what are the activities they have to do, and what are the assets and resources they require to do those activities. So we create this kind of a very rich visual picture that then almost like feeds into that at-scale financial model. Okay, I am going to, before I'm going to hand off to Patrick, I just want to do one little bit of a call to action. And it's just that I really feel like in the world of startups, like we're at this inflection point today. Money's getting a lot tighter, and just every day, there's problems that we need to be solved in the world. Just keep growing. So we've got to be innovating these new ventures, and the only way they're going to actually have impact is by being profitable. And after this journey, it's just I know that systems engineering and IVE, we can create that step change in the success rates, but we fundamentally have to really kind of change the paradigm for how people think you should be innovating these ventures. And on that note, I'm going to hand off to Patrick, and he'll give you a little bit of explanation of how you can get involved and actually be part of that revolution.
Thanks, Eric. So we're at this point where we've been applying this methodology to dozens of ventures and assisting corporations in this. And, we're wanting to take it to the next level. How do we equip a broader community to tackle this, particularly to displace the lean startup paradigm, which is so prevalent? I worked with Erik on the BOP protocol years ago, but then I went into industry and worked at my own startups, worked at Facebook, worked at Automatic, advised a number of companies, and it's very prevalent there. This all the problems that Erik addressed. So how do we go about changing the paradigm? What we realize is one of the things we need to do to bring this new knowledge to people is, one, attract the right practitioners. The other is try to find a way to catalyze not only learning, but the development of new tools and real world applications that people can take it into their own domains. And so can you just click forward? So our solution to this has been the creation and founding of what we're calling the Market Creators Lab. This is a collaboration, and you're missing INCOSE on the end there underneath the reminders, but it's a collaboration between our firm, Half Solved, Cornell University, where a lot of this work was originally done, and there we go, and INCOSE. So go ahead and click ahead. So the Market Creators Lab, which we launched last month, is a membership-based organization. The primary people it brings together are entrepreneurs, investors, and researchers, but practitioners in general that are interested in figuring out this new paradigm for market creation ventures. The methodology or how people interact is it's in the MCL. We're tackling real-world market creation challenges. We have venture building going on, there's collaborative research going on, and ultimately there's knowledge sharing that's going on among the community. You can see the different actors there. We have entrepreneurs in residence, faculty researchers involved, and then investment fellows, venture fellows. And then we're also attracting investors and just different types of innovators and innovation program managers. The idea is that members within the MCL can observe, practice, and harness IVE for their own domains in a supported environment. So supported by the community, supported by the people that have been working on this and developing it. But ultimately, it's about taking this core technology that IVE represents and how to use it and apply it to different domains. Go ahead, Erik. So how it works, like the prime function, borrowing some degree from how INCOSE is organized around technical working groups. The main way that we do this is around member-driven working groups that focus on particular market creation challenges or applications of integrative venture engineering. These working groups house small group research initiatives that iterate over time, and they're focused on defined questions or creating publicly available case studies, tools, and practices, really. So the research happens, it's applied research, comes out either development of tool or knowledge, and that thing is put into the public domain. Research is, the research initiatives are directed by the MCL team and supported by entrepreneurs in residence, as well as faculty and graduate student fellows. Members that join the MCL, you're encouraged to join research teams and participate to the extent you're possible. This is both not only to improve the quality of what gets generated in the MCL, but also to accelerate dissemination of the outputs. I mean, the goal is to be able to bring people in along to practice and use IVE together, and then take it back to where they are or use it in their own domain. Skip forward. So participating in the MCL, INCOSE members can participate in the MCL. The path forward is join the INCOSE Integrative Venture Engineering working group, and you gain a free membership in the MCL. So join it via INCOSE, and we'll get the notification that you joined, or the chairs of the IVE working group will get the notification you joined, and we'll send you a link to onboard to the Market Creators Lab. This includes access to the MCL digital community, which you see here, which is where a lot of our interactions take place. You'll see the research is already being published there. There's an example there of an event that was at Cornell's Entrepreneurship Week just earlier last month. You can see that, recordings of that. You can see published papers and interact with other members of the community. To learn more, you can visit marketcreatorslab.com or just scan this QR code. That'll take you there. Yeah, and we'd really excited to have you join us within the Market Creators Lab. And Erik, if you want to, or Mark, you want to wrap up?
Yeah, I'll just say if I'm glad the email's highlighted here. If anybody has any questions about IVE as a methodology or joining the Market Creators Lab membership in that, you can reach out to me at mark@marketcreatorslab.com. And I think that's it. Anything else to wrap up, Erik?
No, just a big thank you to everyone for bearing with us. I know we're a little bit over time, so and we look forward and really excited to connect with people.
Yeah. So maybe we can end the recording and then we can address a few of the questions in the Q&A. Andy?
I'll leave the recording going. Thank you so much for this informative presentation. And thank you to the audience for your questions. Mark, looking through, are there any that you would like to respond to now?
Yeah, I think there's one that just seems particularly relevant. Iona, I believe it's asked it. Are we applying these concepts, the IVE principles, to businesses from all fields or just specific ones? I think that one's really critical. We get that question all the time. So maybe Erik or Patrick, you could speak to the diversity of different industries you've worked across in your research, and just on a rationalistic basis, how we can apply it to different fields.
Yeah, no, thank you for that question, because that is key. So we've just the fortune we've had is we've been able to apply this in a wide range of industries. It's been everything. There's been consumer products, FMCG. There's been in nutrition and healthcare. It's been applied in finance. It's been applied in like a what do you call it? We'd say a hardware, in off-grid solar. It's been applied in automotive services with BMW UK. It's been applied with Disney and entertainment. So we've really cut across a whole bunch of different industries, and our intent actually, and that's actually would be really great with the Market Creators Lab, in order to be able to like bring it into some areas and domains that we haven't really been able to explore as much, because in as much as like anything, these core principles, practices are going to apply, there's always these idiosyncratic things that come up in any industry or any application. Like if we're going to do something in a really big, huge CapEx type of a thing where you got to build a massive factory that, has this really long kind of learning curve associated, or you've got to put down, lots of big costly, capital infrastructure up front. And so we're actually really excited, to be able to explore and look at the unique kind of issues that have to be addressed when we take this into other industries.
I would even say that, we're a lean startup, as Mark mentioned, really got its basis was in the software industry, which is where a lot of my background has been. And it's interesting just to think about how times have changed. In the time in which lean startup being prevalent and the type of growth that you're able to achieve, there was a lot of relatively free, zero interest rate investment money that could go in. Your cost structure is really, really low. Marginal costs seem to be close to zero, and really were zero in most cases. But if you look at the world today, it's different. Money costs something. It's a very saturated market, so cost of acquisition is very high. And the other thing is the core technology that most people are turning to today in the software world, AI-based technologies, has cost. It's no longer just sort of like, you can bring in another customer that can use your product as much as possible, and you're really not increasing your cost basis at all. That's all changed. And so you're increasingly seeing the ability for something like the systems engineering approach or something specific like IVE being applied to the software world as well.
Yep. And we just released a research paper as one of our first initiative on the unique challenges of hard tech. And we define hard tech as anything that has a significant barrier to redesign or redevelop. Anything with a super long development timeline, anything with very high regulatory hurdles. The idea of iterating a product and redesigning it is untenable. This applies to defense, aerospace, food tech, biomedical, especially med devices, for example. Once you've locked in the product form factor, the likelihood of you iterating and introducing an entirely new product form factor is close to nil. So the concept of MVP is just untenable within any of those industries.
Any other questions you'd like to address?
I think that was it for now. These other questions I'd like to take offline, and I'll tag each person and I'll shoot you an email, and we can field those questions through the Market Creators Lab member forum.
Okay, thank you again for this great presentation. Could I have the next slide, please? So a few quick reminders. You can access this material and for the previous 180 webinars through the professional development portal. And also attending a webinar does count as 1 PDU credit towards your SEP renewal. And a reminder that the INCOSE 2025 International Symposium is approaching us fast. It's the end of July in Ottawa in Canada. Next slide, please. So thank you again to our sponsor, Dassault Systems, for their continued generosity and support of the 2025 INCOSE webinar series. And thank you all again, and we hope to see you again next month.
Thanks, everyone.